waters of the Pacific Ocean welcomed the 4 human beings who traveled furthest in the history of our species. The Artemis 2 mission has ended successfully. They are home. But seeing the Orion capsule floating peacefully under its massive parachutes hides the true terror of what just occurred. Because to achieve this perfect splashdown, this crew had to survive a descent that defies the laws of physics. How did NASA execute the most dangerous, hottest, and most precise descent of the last 50 years without losing the crew? Stay until the end of this video, because we are going to break down, second by second, the engineering miracle behind this physics. You will discover the absolute tension of the radio blackout, the secrets of the skip entry maneuver, and exactly how we arrived at this historic moment.
3, 2, 1, booster ignition.
Imagine it for a second, hitting the invisible wall of our atmosphere at 40,000 kilometers per hour. At that speed, air friction doesn't just generate resistance, it creates an absolute hell. Almost 2,800 degrees Celsius surrounding the spacecraft. That's half the temperature of the surface of the sun and nearly 3 times hotter than erupting volcanic lava. And right in the center of that ball of plasma and fire, 4 people are locked in a cabin the size of 2 family SUVs, trusting their lives to a state-of-the-art heat shield. The margin of error for this maneuver, known as skip entry, was literally 0. If the capsule entered the atmosphere 1 millimeter steeper than required, the entire ship would disintegrate in milliseconds. If it entered 1 millimeter flatter, it would bounce off the atmosphere like a stone on a lake, lost in the darkness of deep space forever. To understand the feat NASA just achieved, we have to forget everything we knew about how the Apollo ships returned in the 70s. Back then, capsules fell from space like meteorites, direct, fast, and taking all the heat in one single blow. It was effective, yes, but brutal for the ship and the astronauts, who felt up to 7 times the force of gravity crushing their chests. Furthermore, they were entirely dependent on ocean weather. If there was a storm in the splashdown zone, the situation became extremely dangerous. But with the Orion capsule on Artemis 2, engineers decided to change the game. They implemented a maneuver that sounds like science fiction, the skip reentry. Remember when you were a kid skipping a flat stone across a lake? Orion did exactly that, but using Earth's atmosphere as the water. At 120 kilometers high, the capsule hits the first layers of our atmosphere. The heat shield, the most advanced barrier ever built, takes the first brutal impact of those 2,800 degrees. But instead of continuing down and letting the heat accumulate to the limit, the ship uses its aerodynamic shape and air resistance to generate lift. Yes, the capsule literally flies back up, momentarily jumping out of the densest part of the atmosphere. This jump gives the capsule a few life or death minutes to cool down. It's like pulling your hand out of the fire just before you get burned. Then, with less speed and less accumulated heat, the ship makes its final descent toward the ocean. But this bounce isn't just to protect the crew from the fire. This maneuver allows the onboard computer to pilot the capsule and extend its flight by thousands of additional kilometers if necessary. This means NASA can now choose, with sniper-like precision, the exact spot in the Pacific Ocean where they will land. Right where the Navy recovery ship is waiting, dodging any bad weather. It's the equivalent of throwing a baseball from New York and having it land exactly inside a glass of water in Los Angeles. However, mastering physics doesn't mean eliminating the tension. While Orion performs this dance of fire in the sky, Earth experiences the most harrowing moment of the mission, the dreaded comms blackout. When the ship hits the atmosphere, the heat is so extreme that the air around it ionizes and turns into plasma. This plasma acts as an impenetrable wall of electrical energy that blocks all radio signals. During those endless minutes, mission control in Houston, the astronauts' families, and the entire world are left completely blind and deaf. No telemetry, no voices over the radio, no data blinking on screens. It is an absolute deafening silence. Imagine the feeling of waiting for a vital call that never comes. You have the most advanced technology on the planet.
And as predicted, we've entered our communications blackout.
But for those minutes, it's useless. You can only watch the clock, hold your breath, and wait. In the minds of every NASA veteran, a terrifying ghost lingers. The memory of the Space Shuttle Columbia tragedy in 2003. They know perfectly well that at these speeds, if a single heat shield tile fails, or if a sensor gives a wrong reading, the capsule would disintegrate in the upper atmosphere. And Houston wouldn't know until it was too late. Until, suddenly, a voice breaks the static over the speakers.
Integrity, Houston, comm check, post-blackout.
Houston, Integrity, we have you loud and clear.
The capsule has survived the inferno. But the mission isn't over yet. We're coming from 40,000 kilometers per hour, and now we must stop this 10-ton machine so the impact against the ocean isn't fatal. Here comes one of the most complex and reliable braking systems in modern engineering. It's like driving a Formula One car at max speed and trying to slow down to a bicycle's pace, all in less than 5 minutes, hanging only by a few threads. At about 7,000 meters, the air is dense enough for the next step. The first parachutes deploy.
And there go the first series of parachutes, and we're on drogues.
These aren't the mains. They are 2 small drogue parachutes made of reinforced Kevlar and nylon, designed exclusively to stabilize the ship and provide the first sharp tug against the wind. Once stabilized, the crowning moment arrives. The 3 massive main parachutes deploy.
Main chute deploy.
When fully open, they cover an area nearly the size of a football field. The contrast is brutal and fascinating. The capsule goes from being a supersonic fireball to descending gently, swaying in the wind over the blue ocean. The speed drops drastically. From those initial 40,000 kilometers per hour, Orion prepares to touch the Pacific waters at just 32 kilometers per hour.
Houston, Integrity, splashdown, sending post-landing command now.
Splashdown confirmed.
Copy splashdown, waiting on VLDR.
A new chapter. The hit against the water kicks up a curtain of white foam. Immediately, flotation systems inflate like giant life jackets to keep the capsule upright. Navy helicopters and fast boats, already positioned just kilometers away thanks to the skip precision, surround the area in minutes. When the recovery teams open the hatch and the 4 astronauts breathe fresh air for the first time in weeks, they aren't just finishing a trip. They are closing one chapter of history and opening another, immensely larger one. It's designed to fly up to 4 different missions, completely changing the rules of the economics and speed of modern space travel. The Artemis 2 mission proved we can go further, that we can exceed the limits of the legendary Apollo 13, and above all, return home using cutting-edge technology. Now, With the resounding success of this feat, the world's eyes are set on the next monumental step. In mid-2027, the Artemis 3 mission will launch to test landing and docking systems in Earth orbit, definitely paving the way for the most anticipated moment: the return of humans to the lunar surface in Artemis 4. We returned to deep space. We mastered the return, and this time we are preparing to stay. Tell us, what do you think about the return to the moon? Is there something we missed? Let us know in the comments below. If you enjoyed this video and want to discover many more air stories, subscribe and click the notification bell. It would help us out a ton.